Hello and welcome to the second video from Lesson 1.1. This is 1.1b, video 1.1b. It is still on Lesson 1.1, which is Relations and Functions, but it's just the second half of the back page. So make sure, again, you are taking notes along the way. As you watch the video, you have your pencil in your hand, you have your notes in front of you, you're stopping when you need to, rewinding if you need to. Let's go ahead and get started on the notes. All right, on this page, we're going to be talking about function notation. And function notation is a different way of writing things. One thing you need to understand, well, let me just get started. I have some notes up here. Let's kind of ignore those notes just for a second and talk about the blanks over here. So sometimes we say y equals 5x. And sometimes we say f of x equals 5x. F of x and y are really just the same thing. And that would go in the next blank. F of x is another way of saying y, but it has more functionality. It can actually do more for us because that f of x is kind of like a placeholder. So we could say, well, what's f of 1 or what's f of negative 1? And we could plug that in. So f of negative 1, if I plug in a negative 1 to this x, I would also plug in a negative 1 to this x, and that would give me a negative 5 for my f of x value. Or is also called y equals negative 5. And so f of x does not mean multiplying. Sometimes people see that and they see the parentheses and they think it's times. It is not f times x. It's not. We say f of x. And sometimes as teachers, we kind of run that together, say f of x, and say, what did they say? F of x. That's what that means. And it means like I said, the x is a placeholder. We can plug things in. So f of negative 1 means plug in a negative 1 for x and work it out. Now f of x can also be used on a graph. So f of negative 4, well, remember that it's f of x. So that means our negative 4 is our x value. So here's negative 4 on my x's. And so where is the function at that point? Well, it's up here at 8. So f of negative 4 is equal to 8. And if we were going to make a table, we could put any numbers into this table because look, we could go anywhere along there and we could find an answer, right? So the only one we had right now was a negative 4 and an 8. Now we could put other stuff in there too. Maybe negative 9 and let's say 1.5. So this f of x is just another way of saying a point. F of negative 4 is equal to 8 is actually equivalent to the point negative 4, 8. Right? Look over here, negative 4, 8. It's just a point. Negative 4, 8 is a point. Okay, so the function notation is f of x. It really just means y, but it is a little bit more than that because it allows us to plug in numbers. Okay, now we're getting to a slightly different concept. This concept is going to be new to you, and it's kind of confusing because you almost think, why do we have this other one when the other one worked pretty well? Here's the deal. Do you remember when you had inequalities? So if we look at this number line and look at this top one, for instance, could we come up with an inequality for m? Well, remember, the variable is all of the things on the line, right? So we could say that m is greater than or equal to negative 6. Okay, do you remember that? That the negative 6 is a solid dot, so it has an equal to with it, and the line is everything greater than that. So m is greater than or equal to negative 6. If we look at the n, the bottom one, then we would say n is less than 2. And this time it's an open dot, and since it's an open dot, we do not have an equals, but it's everything that's less than 2. N is everything that's less than 2. Okay, that you should know and remember from middle school or maybe even elementary school. But now we're going to interval notation, and that's a little bit more confusing. Not confusing, it's just new. And since it's new, it's different. The interval for m, if we were going to rewrite this instead of as inequality notation, if we were going to write it as interval notation, we would say this goes from negative 6 all the way up to infinity, right? Can you see how that's going to go to infinity? So we're going to say it goes from negative 6 to infinity. Then we're going to put a square bracket on our negative 6 because it's a solid dot. And we're going to put a rounded parentheses on the infinity because it never actually gets there. The parentheses mean it never gets there. The squared off means it does touch it. So how about n? N is everything less than 2. Well, note in the margin here, and write this down, we always start at the lowest point. So on the top m line, I started at the lowest point, that was -6. On this line, my lowest point is negative infinity. And it goes from negative infinity all the way up to 2. Does it ever get to negative infinity? No. Does it ever get to 2? Also no, because it has that hole, right? And that hole means you don't actually get there. So off in the margin, let's write something down. Okay, off in the margin, let's say if it is a solid dot, that means it's less than equal to or greater than equal to, and it means we have square brackets. If it is an open dot, it does not have an equal sign. It's just less than or greater than. And if it's an open dot, it doesn't have these square parentheses, it just has regular parentheses. Okay, let's look at this example. These are a little bit tricky because we're dealing with domain and range, and we want intervals. So there's kind of a lot going on. And the graphs weren't numbered for us. So take a second to count off and see how far away these things are. The domain starts down here at -7 on the x and goes all the way up to +5 on the x. Does it hit the -7? Yes, it does. Does it hit the 5? No. So my domain is from -7 to 5. It includes -7. It does not include 5. The range is the up and down, the y values. And so that point over here, it always starts at the lowest point, whether it's the left or the bottom. So we're going to start at the lowest point. The lowest point is -3. So our range goes from -3 all the way up to 1. Does it include the -3? Yes, it does. Does it include the 1? No, it does not. Okay, number 2. Again, we're going to be talking about domain and range. Domain is the x values. It starts over here at 0, and it goes how far? Well, it goes to infinity. Does it ever get to infinity? No. Does it get to 0? Yes, it does. It does not have a big fat dot on it, but it gets there. If we zoomed in on it, it would still hit the origin there, so it does. The range is my y values. The lowest point it gets to is 0. The highest point, this is going to keep going a little bit up all the way. So it is also going to a positive infinity. Never gets to infinity because infinity is impossible to get to, but it does touch that 0. We talked about that. Okay, number 3, domain and range. This one is a little bit tricky because look at this gap. One thing I want to tell you is this would be considered, this is not continuous because there's a break. If there is a break, it is not continuous. The domain goes from -infinity all the way over, and now this is tricky. This is the tricky part right here. It looks like it goes over to 1, but it never gets there, but actually it does. Look, it picks up again here. So my range, there's actually not a break in my range. Excuse me, my domain. There's not a break in my domain. So I'm going to go all the way from -infinity all the way over here. I jump up here, didn't break it. I know it looks like a break, but the domain didn't stop. And then it goes all the way over to positive infinity. Never gets to either one though. Okay, how about the range? For the range, we always start at the lowest point. What's our lowest point? Lowest point is -infinity. How high does it go? Well, that's kind of strange, isn't it? I'm going to do something. I'm going to take this line because range tells us how high up or down things go. So the range starts down here at -infinity. It goes up, 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 up. Is there a break in the range here? No, there's not. There's a break in the line. It's not continuous, but there's not a break in the range. It keeps going all the way up here, all the way up here until this point. After that, there's no more. But it did exist in all these places. And so it goes all the way up to, it's kind of fuzzy, but I think that's a 4. And we do put a brace on it because it is a solid dot there. Okay, that is it for this day's notes. Here's what I want you to do every time, is write down a couple things you need to remember. And so things you need to remember, write those down. We will talk about that in class when we come back next time.